And so we've been looking at this average rate of change formula, or sometimes we call it our slope formula or our slope function. And what it does is it tells us the slope of the secant. And of course, what we want to do is find something that tells us the instantaneous rate of change when these 2 points that make up the secant get right on top of one another. But we know for a fact that the system breaks down then. We get 0 over 0 and we can't calculate the instantaneous rate of change. So unfortunately, this formula is not an instantaneous rate of change formula. It's an average rate of change formula. However, if I introduce this whole concept of a limit, I can get rid of the whole 0 over 0 problem. Get out of here, undefined. And so basically what taking the limit means is that we can get a really good idea what the actual instantaneous rate of change is at that point just by seeing where the slope is headed as these points get closer and closer together. And so even though I can't really calculate the instantaneous slope, I'm going to say, well, this is really headed for negative 5.07. I can say that that's pretty close to being the instantaneous rate of change. I am taking the limit. Even though I can't calculate it exactly when the points are on top of one another, I can guess at what that slope is going to be.